Short TEER is the transepithelial and transendothelial electrical resistance. It is a widely used non-invasive method to assess how well epithelia or endothelial cells form a functional barrier in vitro. And basically, the electrical resistance, which is measured across the cell layer, gives us an idea of how intact or differentiated the monolayer is, especially if the cells are forming strong tight junctions. And it's also a simple and fast readout. It's commonly used in static culture, and it gives a first indication of barrier quality before moving on to more complex analysis. Before TEER became more widely used, permeability assays were the standard method to evaluate barrier integrity in vitro. And while there are still valuable tools, comparing both methods reveal key advantages of TEER measurement. So let's take a closer look at how TEER and permeability assays differ, in this case in a transval. So permeability assays rely on a labeled tracer molecule to see how much of this tracer molecule passes really through the cell layer over time. But TEER, on the other hand, uses an electrical current to measure the resistance across the monolayer, which then reflects how tight the cell junctions are. And in terms of timing, permeability assays can take anywhere from 1 to 24 hours, depending on the setup, whereas TEER measurements are much quicker, often just a few minutes or seconds. And when it comes to compatibility, the permeability assays could interfere with cells or drugs, depending on the tracer used. And TEER is a less invasive method. In that sense, it has a limited interference with cells and drugs. But its accuracy can be quite sensitive to experimental conditions. Things like electrode type, as you can see here, the chopstick electrodes, the membrane area, or media temperature, that can all influence the outcome. So both methods have their strengths and limitations, and they are often used together to get a fuller picture of barrier function. But compared to these in vitro methods, like the use of chopstick type electrodes in transfer cultures, the TEER electrodes in our chip platform are incorporated at a fixed position without being movable, and therefore it provides a more accurate and stable measurement with less sensitivity distribution. So that's a big advantage in comparison to the chopstick TEER measurement. And here you can see a schematic of the chip where we equipped our biochip with semi-transparent planar gold electrodes. And in this explosion view, you can see that the electrodes are positioned at the inside of the chip, of course attached to the top and the bottom bonding foil. This enables you to get a readout throughout the tissue and check if the barrier is intact or not. And we also added an additional circuit board that is attached to the chip. And this circuit board enables the contacting of the electrodes and the signal transmission. And here you can see how it looks in real life, how our chip looks in real life from the front, from the top view and the bottom view.